Oh, tu nanti saya beritahu. Okay, alright. So saya terus, nanti saya beritahu. Okay, so push yourself because no one else is going to do it for you. So tolong push yourself. Sekarang ni kita dah week 8, so kita finish dekat week 14. So lagi tinggal 7 weeks lah. Ya ke 7 weeks? Betul lah. Ya ke? Tinggal lagi 6 weeks to go. Okay, so tolong kuatkan semangat. Okay, so ini adalah contoh. Tapi tak ada music. Saya tak tahu kenapa music tak nak. So this one is adalah dia punya contoh application of electromagnetic induction. So kalau you tengok this one, dia ada apa benda ni? Okay, actually this is coil yang ini coil. So ini adalah coil, yang ini adalah straight wire. Straight wire adalah conductor. So bila you letakkan current, so dia telah menjadi current carrying conductor. So dia telah menghasilkan medan magnet lah. So bila dia menghasilkan medan magnet, dia menghasilkan magnetic field line. So that's why benda ni boleh berpusing because dia adalah from north pergi ke south. North pergi ke south, north pergi ke south. So that's why dia boleh bergerak. Sebab dia ada magnetic field yang menggerakkan dia daripada north pergi ke south, north pergi ke south. So ini adalah salah satu contoh application of electromagnetic induction. Video ni you boleh cari lah dekat TikTok, banyak ni rasanya. You type je electromagnetic induction, you can see banyak eksperimen yang diorang guna ni. Okay, so kita pergi kepada electromagnetic induction. So dia adalah 6 hours. So last week we already go through the electromagnetic induction. Kita dah go through magnetic flux dengan induced EMF. Magnetic flux kita dah pergi kepada phi. Ingat tak ya, phi equals to B dot A mesti BA cos theta. So ada some assignment cikgu yang ni berkait dengan chapter 5 here. Sebab theta here it should be between B dengan A. Okay, boleh? Alright. Alright, so kita masuk kepada seterusnya. Alright, so kita masuk kepada magnetic flux linkage and then Faraday's Lens law, conductor, coil and solenoid. So yang ini kita dah go through magnetic flux linkage, jedarak, Faraday law. So remember back what Faraday said. Faraday cakap induced EMF is only can produce where it is equal to the magnetic flux over dt. Okay, lepas tu kita masuk pula kepada induced EMF. Induced EMF dah kita dah masuk. Okay, lepas tu Lens law. So kalau you ingat balik Lens law cakap Lens law kata induced current is in a direction oppose the change of magnetic flux. Itu adalah Lens law. Okay, and then kita dah go through kepada conductor. So kita ada tiga jenis conductor iaitu wire, straight wire. Yang ni semua formula untuk straight wire. Yang ini adalah untuk formula untuk coil. Kita ada dua. One is the change due to the magnetic field. One is the change to the area. And the last kali kita belajar pasal coil tapi dia rotating. So kita ada NBAO, formula kat sini tertinggal omega, nabau. Budak saya kata cikgu nabau. Nabau sin omega T. Okay, so that is the formula. Okay, so hari ini kita akan masuk kepada we will go to the self-inductant, energy store and mutual inductant. Okay, so electromagnetic induction inilah Mr. Faraday ni kalau you ingat balik ini Mr. Faraday, dia yang discover lah. Dia menggunakan Hans Christian Ørsted punya works. So dia found that when there are wire, there are when the wire is combined with magnetic strength and current, so dia akan menghasilkan induced EMF. So dia menghasilkan voltage dengan menggunakan magnetic field. So itulah dia punya Faraday punya ni lah. Okay, so kalau you tengok ini magnetic induction, as the magnet move back and forth, a current is said to be induced. Kenapa? Because they are changed. So induced EMF is only can be produced when they are changed. So tolong ingat ya, this one you have to remember. We only can produce induced EMF when they are changed. Apa beza induced EMF dengan EMF? EMF is come from the battery or power supply. But induced EMF is happen when they are changed. So dalam kes ni dia move back and forth. So dia bergeraklah, dia gerakkan this one, the magnet back and forth. So they have a current can be produced. So when the current can be produced, so actually dia ada voltage. So this voltage we call it as induced EMF. Dan current yang terhasil tu kita panggil dia induced current. Okay, ini kalau saya ada banyak cakap lah dekat my tutorial class that forever flashlight. Ini menggunakan Faraday principle electromagnetic energy where they eliminate the needs of battery. The Faraday principle state that if the electric conductor like copper wire is moved through a magnetic field, the electric current will be generated and flow into the conductor. So if you look at this, nama dia adalah forever flashlight. You boleh Google forever flashlight ni. They not use any battery. So tapi dia menggunakan principle of Faraday's. Dia guna Faraday punya principle where when the copper wire is moved in magnetic field, the electric current will be generated. So what happened here? Kalau you tengok this one masa dia zero bila dia on. Okay, in the first 7 minutes, the night star will be illuminate. Dia illuminate very big lah, paling besar lah. Okay, lepas tu 7 to 40 minutes, the night star safely illuminate and walking path at the night. Okay, between 40 to 20 minutes, the night star provide enough light to easily read a map. So ini digunakan dalam, kalau you pergi hutan ke, you pergi camping ke, you can use it lah because dia without battery. Dia boleh bertahan dalam 20 minutes. Tak lama lah 20 minutes. But without using a battery. So 20 minutes without using battery. But when you nak guna balik, you just goncang lah, dia akan datang balik lah light tu. Okay, ini contoh lagi lah, you guna induction stove. So induction stove also, why this stove work with, will this stove work with ceramic bowl? Adakah dengan ceramic dia boleh buat atau the surface of the stove get hot? Okay, panas tak ni this one? Okay, so kalau you tengok ini without using gas ini menggunakan electric. So what happened here? The water in the metal pot only will be boiled, but for the glass dia not boiled. Why this happen? So ingat balik, Faraday kata the induced EMF is only happen when they are changed in magnetic flux. So magnetic flux we are talking about here mesti adalah conductor. So glass is not a conductor. So that's why the glass pot is not boiling lah. And the stove top is cool to be touched. The stove operated in this way by using electromagnetic induction. So ini example lah yang kita nampak lah menggunakan konsep electromagnetic induction. So there's a lot of application lah untuk ni. Alright, okay, so ini salah satu contoh lagi lah. Yang ini pun you boleh tengok lah dekat ni. Kalau you tengok ni, okay, ini adalah induction heater completely melt lah. Okay, yang ini adalah coil yang macam you dalam you punya apa, boiling tu, water tu apa, water tu ada boiling coil lah. Okay, coil ni tidak di on but what happened, dia oscillate, magnetic flux oscillate and the coil does not heating up. Kita tak heating up pun the coil. But why this is melting? Sebab dia telah berlakunya electromagnetic induction. Ini salah satu contoh lah electromagnetic induction. Yang ini you boleh Google. Dan ini pun cikgu jumpa dia dalam TikTok. So you can go through lah back yang ini. So nanti dia akan fall down lah the molten. Molten ni adalah follow and grow your brain. Okay. So kita tengok sekali lagi. Itu adalah contoh je lah. Okay. Alright. So itu adalah idea of the electromagnetic induction. So today we will learn about self-induction. Okay. Self-induction, the symbol is L. So at the end of this chapter, students should be able to define self-inductance, apply self-inductance. So there are 1, 2, 3, 4. There are 4 formula that you need to know lah. Ada 4 formula you need to know. Okay, but you don't have to memorize because all the formula is given lah. Okay, so the first one you need to find self-inductance, apply self-inductance, L equals to negative induced EMF over di over dt. And then for a coil or solenoid where L equals to N phi over I, mu naught N square A over 2R, mu naught N square A over L. So kita ada 4 lah. Okay, kita tengok kepada this one. Okay, self-inductant. Consider a solenoid which is connected to a battery, a switch S and variable resistance R. Okay, so if you look at here, we have a solenoid and we have switch. Before this, kita tak pernah switch, and also we have a battery. The most important thing adalah battery ni. Before this, you tak jumpa battery. You nak create without using a battery. But now we have a battery. Okay, tengok battery ni. So what happened? There are current flow bila you switch on. Okay, bila you switch on, you tengok gambar rajah dia ni. Okay, ni dia switch on. Ni tengok ni, dia switch on. So current flow adalah daripada terminal positif. So this is your current. So akan ada current flow. By using right hand grip, keluarkan tangan kanan, right hand grip, current naik atas, dia masuk macam tu. So your nose should become here lah. So this will become your nose. So you know nose, you punya south. Okay, the current produce a magnetic field whose field line through the solenoid and generate magnetic flux linkage. Kenapa magnetic flux linkage? Because they have a lot of magnetic, they have a lot of N phi here kan. So ini akan menghasilkan N phi, so menghasilkan phi lah, phi besar tu. If the resistance of variable resistor change, thus the current flow in the solenoid also change. So to does the magnetic flux linkage. Okay, so kalau you ingat balik Faraday cakap apa, when the current flow, so dia telah menjadi CCC, current carrying conductor. Firstly, dia hanyalah conductor. Kalau you switch off, dia hanyalah conductor without battery, without a current. So once you ada current, dia dah jadi current carrying conductor. So current carrying conductor is the source for magnetic field. If you remember back, there are 3 sources of magnetic field. Yang pertama adalah bar magnet. The second one is the current carrying conductor. The third one is earth magnetic field. So current carrying conductor pecah 3 lagi. Dia ada 3 shape. Straight wire called solenoid. So solenoid adalah satu source, punca source. Okay. So magnetic field. So by using right hand grip, you masuk sini, so you akan dapat north and south. So what happened here? There are change. Okay. So B initially adalah 0. Why B is 0? Because initially there are no magnetic field. There are no magnetic field. B 0. You tak switch on, there are no B. B is what? B is magnetic. Medan magnet. Tak ada medan magnet. But when you switch on, the B is become largest. Makin meningkat, makin meningkat, makin meningkat. So what happened? There are follow the Faraday law. Because B is changing. So kalau ingat, phi equals to BA cos theta. So B is changing. When B is increasing, delta phi also increasing. So dia telah obey this law, magnetic flux. So ada perubahan in magnetic flux. So akan wujud induced EMF. So this induced EMF terhasil inside the solenoid. So kawan baik Faraday is Lenz law. So Lenz law also akan terhasil. So what Lenz law akan buat? Lenz law kata induced EMF atau induced current is opposed the chain that induce it, known as back EMF. So akan terhasillah back EMF. So this back EMF, apa dia buat? Dia akan oppose the change. Okay. So kalau awak tengok dekat sini, B saya makin meningkat. So wujud Faraday law. So Faraday ada wujud induced EMF. So akan wujud imaginary battery inside here. But how do we want to know which one is positive, negative? By using Lenz law. So Lenz law doesn't like the change here. Dia tak suka B ni meningkat. Dia tak suka. Dia kata jangan B ni nak meningkat. Okay, so apa dia akan buat? He will make the magnetic field opposed. So dia akan buat ini south, ini jadi north. So your magnetic field adalah this one. So by using right hand grip nanti ataupun you just tengok, okay, north dekat sini. So you punya induced EMF dia naik atas macam ni. So induced EMF you should be up lah. So dia kena naik atas. Your I induced should be up. So your positive should be here, your negative should be here. So maksudnya untuk you want to know the direction of induced current and also induced EMF, you have to use the Lenz's law punya. You have to use the Lenz's law punya law lah. Okay, so saya ulang balik Okay. Ni senang je, tak ada pening-pening. Okay, first kali we are talking about Lenz self-inductance is about dia punya sendiri. Okay, so dia ada north and south. So how do we determine north and south? Due to the current flow, because dia ada battery ni, bawah ni dia ada battery. So battery, dia ada battery. So this is your positive, this is your negative. So positive going to negative. Okay, then what happened? There are change in B. Because the B is increasing. The magnetic field from 0, initially is 0 and final is increasing. Bila you switch on je, dia increasing. Okay, so what happened? Lenz's law doesn't like the increasing. Dia tak suka change. Dia tak suka perubahan. So apa dia buat? Dia akan oppose. So macam mana dia oppose? Dia create a new magnetic field. So this new magnetic field is oppose the magnetic field that inside the coil yang that produced by the battery. Dia akan oppose lah. So by using right hand grip, so your north is here. Tengok yang warna biru ni. Your north is here. So north is here. So dia akan naik atas macam ni lah. So north is here, dia naik atas. So your induced current yang warna biru ni lah should be going upward lah. Dia mesti jadi clockwise. So based on that, we can determine dia punya induced EMF. So in this diagrams, kita ada dua kuasa lah. One is from the battery EMF, one is from the induced EMF that we produce by using Lenz's law. Okay, so kalau awak tengok dekat sini, dia kata the direction of induced EMF is opposite the direction of current. Okay, this one adalah case untuk B is increasing. So what happened bila I switch off? Okay, apa maksud cikgu switch off? Okay, ini tadi dia ada battery, betul tak? Okay, saya ada switch. Saya off switch. Switch dia bukan kat sini. Switch dia dekat sini lah. Okay, saya off switch. Saya off switch. So what happened? The B here akan decreasing. So B akan decreasing lah because you suddenly drop the current. So when you drop the current, so what happened? When you drop the current, someone doesn't like. Siapa yang tak suka tu? Lenz. Lenz's law doesn't like the B is dropping. So dia akan oppose the change. So how dia oppose the change? Dia akan make the new magnetic field is same side dengan yang terhasil due to the battery. So dia akan sama like NNSS. Dia akan menolong, sebab B nak jatuh. Macam ni lah self-inductance, saya bayangkan diri you sendiri. Okay, diri you tengah down. Okay, you tengah down, exam nak dekat, you tengah down. So what happened? Takkan you nak kata, tak apalah, lantak lah, biarlah. No, you cannot do that. You have to force yourself. No, you can do it. You can do it. Boleh, you can do it. Betul tak? No one else. Macam tadi yang saya cakap, no one else can do. It's only you. You sahaja. So macam you lah, you nak jatuh ni. So adakah you biar ke? You biar aja diri you jatuh? No. You have to support. You kena support diri you. So you akan follow. Memang dia akan jatuh, going to zero. But it's slowing down the decreasing. Okay? Dia slowing down. Dia akan jatuh, cuma dia slowing down. So the induced current ni, kalau you tengok induced current dia, adalah following the same side. Okay, so the direction of induced current, induced EMF is in the same direction of the current. So dia ikut yang sama. So dia ada dua lah. Satu bila dia meningkat, Lenz's law doesn't like. So dia akan change, dia akan oppose. But one, bila dia menurun, dia pun akan oppose but by using same side. So selalunya student dia akan confuse, dia selalu ingat Lenz's law ni jahat, dia nak oppose je. Maksudnya bila dia clockwise, dia akan jadi anti-clockwise. Bila dia anti-clockwise, dia jadi clockwise. No, oppose here we are talking about change. So bila dia meningkat, dia akan oppose, dia opposite. Tapi bila dia menurun, dia akan follow because dia doesn't want that the B is decreasing. Okay, boleh. Itulah kita panggil dia self-induction. So self-induction is the process producing an induced EMF in the coil. So we want to produce EMF inside the coil due to the change of current following through the same coil. So dia adalah disebabkan perubahan. Okay. Alright, so tengok kepada ini eksperimen self-induction experiment untuk demonstrate the circuit. So if you have here, we have EMF, we have switch, we have lamp A1, lamp A2, one is the iron core, one is resistor. Okay, so dia dalam bentuk parallel lah yang itu. So initially variable R is adjusted so the two lamp have a same brightness. So dua-dua have the same brightness lah. So lamp 1 and lamp 2 have the same brightness. When the switch S is closed, the lamp A2 with a variable R is seen to be more brighter almost immediately, but A1 with iron core L increase slowly to the full brightness. Okay, dia kata when dia switch on ni, A2 immediately terus brightness, but A1 dia tidak brightness. Okay, kenapa? Sebab dia ada this one. This one adalah conductor dalam bentuk coil. So if you remember back, if we have a current, so dia dah jadi CCC, current carrying conductor. So when dia terjadi current carrying conductor, they will produce magnetic field. Sebab dia adalah source of magnetic field. So bila dia menghasilkan magnetic field, dia telah ada change in magnetic field. When they are changed in magnetic field, they are changed in magnetic flux. So dia telah menghasilkan induced EMF. So dia dah obey Faraday lah. So apa bila dah ada Faraday akan wujud lens. So apa lens law kata? Dia menentang. So that's why you akan nampak lamp A1 dia slowly. Kenapa dia slowly? Sebab dia ada orang menentang dia. That person is Lenz law. Lenz law dia kata, jangan B tu nak meningkat sangat. The B doesn't have to be bright, tinggi cepat. So dia akan slow down. But will be increasingly, but dia akan fully brightener because you switch on je. Dia akan but slowly. Contohnya lampu kelap-kelip, lampu hari raya tu kan. Brightness is very lambat sangat. Itulah contoh dia. So ini example. So the most important about self-inductor ni, kalau you nak adjust your lamp not lambat-lambat, ada timing ke, ada timer ke, dia lambat untuk capai dia punya full brightness. Okay, so macam saya cakap lah tadi lah, because they have a self-induction lah dan ada induced EMF, so they ada back EMF ataupun induced EMF ni oppose the growth of the current. However, untuk R, there are no back EMF, so that's why A2 is go full brightness. Okay, so ini adalah contoh untuk lamp A2 kalau kita buat eksperimen and then kita conduct dia punya I. So untuk lamp A2 dia punya current terus naik, dia direct naik. But for lamp A1 dia lambat lah, dia lambat. Saya pulang balik ya, cepat. Okay, so ini lamp 1, dia akan naik for the maximum but very slow. Okay, so ini adalah contoh lagi lah. Yang ini saya tak bagi example ni. Okay, kita terus tengok kepada formula. Okay, this one, the one that we'll use lah dalam exam. Okay, phi sama dengan directly proportional to I, di mana when you I increasing, so you punya phi pun akan increasing. So what is phi? Phi tu adalah magnetic flux linkage. Okay, L adalah self-inductant, I is the current, phi is the magnetic flux linkage. From Faraday law, EMF equals to negative magnetic deflux over dt. So d phi tadi sama dengan Li. So Li you substitute here. So you will get, because the change is only for the I, so L bawa ke depan, so you get phi equals to negative L d I over dt. So that is the first equation. Perlu hafal tak? You don't have to memorize, it's all given in the exam. Okay, you just have to know what is I, what is L. Okay. So, self-inductant is the ratio of self-induced back EMF to the rate change of current. So, dari situ tadi EMF sama dengan negative L di over dt. So, you make it L a subject. So, L equals to negative phi di over dt. So, when we have N call, itu untuk one kalau ada N call, so you just substitute ini Faraday punya equation kalau remember balik. Phi equals to negative dv over dt. Kalau ada N just darab dengan N. So V equals to negative L di over dt, yang ini baru belajar tadi. So you substitute both, make it same simultaneous equation. So what happen here, kalau you tengok, dia integrate here. So negative can cancel. So when you integrate di over dt, so you get I. So when you integrate dv over dt, you get phi. So you get Li equals to n phi. So L equals to n phi over I or phi over I. Ingat balik this one I say this one is capital A, yang ini capital ini small a. Dua-dua ni nama dia adalah phi. Ini adalah Greek punya language lah. Okay. So that is the second equation. Ini first, this is first, this is second for L. Okay. The third one, tak apa jangan risau because this all given, you just have to know. Soalan bagi apa baru substitute. Okay, unit, this is scalar quantity. Okay, when scalar quantity, you tak perlu risau lah because you don't have bother about the direction. Okay, the unit adalah Henry, capital H. So 1 Henry equals to 1 WA, WB, Weber, A negative 1 or Tesla, M squared, A negative 1. Self-inductance is depend on the size and shape of the coil, number of turn and probability of medium in the coil, mu. Okay, a circuit eliminate element which possess mainly self-inductance known as F-inductor. So they can store energy. So ini contoh adalah untuk gambar untuk inductor lah. So selalunya self-inductor ni simbol dia adalah solenoid. Okay, self-inductor in circular coil. Okay, we know that formula for circular coil. Saya rasa ramai dah buat assignment. So you known lah untuk formula ni, B equals to mu naught Ni over 2R. So when there are magnetic flux through a coil, so apa berlaku? Magnetic flux equals to VA cos theta because it's always maximum. So from here, this B, the substitute here, mu naught Ni over 2RA. So you get mu naught NIA over 2R. So dari situ, L tadi you know equals to N phi over I. So phi ni dia masukkan untuk coil punya. So formula, so mu naught NIA over 2R. So you will get L equals to mu naught N squared A over 2R. So this is the third formula for self-inductance. Okay, apa beza yang tadi? This one is only can be happen for the coil. So bila nampak soalan ni O2R, that is for the coil. Okay, yang tadi, this one yang tadi mana yang tadi? Yang ini can be both untuk semua. Tak kisahlah bentuk coil ke, solenoid ke, can. Because this is general. Number 1 and number 2 can be both untuk tak kisah mana-mana. Because this is general. Okay, yang the third one tadi tu only can be used for the coil only. Okay, ada 5 tadi kan? Okay, satu lagi adalah untuk solenoid. If you remember back, the B, the magnetic field for the solenoid is mu naught Ni over L. So when it is at maximum, so mu naught Ni over L because cos 0. So you substitutekan B inside here. So you get mu naught Nia over L. So your self-inductance L equals to N phi over I. So phi ni dia masukkan yang ini. So you get Ni constant mu naught Nia over L. So that's why you get mu naught N squared A over L. So this one is only the fourth equation is only can be happen for solenoid. Okay, so in exam, you don't have to memorize all the equation, but you just have to know what the equation that you need to know, you need to use. For example, let's say here we have 500, so N. Solenoid, dah. You just guna formula solenoid lah. Apa formula solenoid? You pergi dekat nyawa depan, you ada satu formula solenoid iaitu L sama dengan mu naught A. This one yang tadi tu. Mu naught N squared A over L. So make sure you use this. Jangan guna yang coil punya. Okay, so apa yang dia bagi lagi? Dia bagi N, dia bagi solenoid, dia bagi length. When the current of the solenoid is increasing, so I initial 0, I final is 2.5 within 0.35 second. The magnitude of induced EMF, so ini dia bagi EMF is 0.012. So calculate the induction of the solenoid. So apa simbol induction? L. So kita nak cari L. Okay, kalau dia cakap induction, the symbol is F. Self-induction, induction is the same thing Okay, so you nak cari L. So macam mana nak cari L? First kali dia guna formula general lah. EMF equals to L di over dt. Ataupun you terus guna formula yang direct to L equals to EMF over di over dt. So L ada, L nak cari, EMF we already given here 0.01 ni ada EMF, di over dt meaning I final minus I initial divide by time. So you will get L. So the L here adalah unit dia H, Henry. Okay, boleh tak? So soalan dia tak susah, very direct because they will give you the equation. Cuma you kena tahu mana yang you nak guna. Okay, yang lain ni saya tak go through lah sebab yang ini adalah just given the formula. Okay, the second learning outcome that you need to know is about the energy stored in inductor. So there are energy stores. First kali you kena derive and use energy store. So U equals to half Li squared. So the symbol is adalah U. So what happened here? So bila ada electric field, so magnetic field akan wujud current carrying conductor. So when they have current carrying conductor, so akan wujudlah back EMF ataupun kita panggil dia induced EMF. So induced EMF ini akan menghasilkan power. So the power, if you remember back, P equals to IV. But V here, we can equals to EMF. Why? Because we don't use battery. The EMF that produced is induced EMF. There are no internal resistor. So P equals to Li. Mana datang formula ni? EMF ni diganti ni lah. L di over dt. So dari sini dt dia bawa naik atas. So you get P dt equals to Li di. So what happened? P dt. Okay. Kalau you ingat balik, power sama dengan work over time. Work tu boleh sama dengan energy over time. Okay, so saya boleh bawa T ni naik atas. So P dt, D, saya letak D lah, D equals to du. Itulah datang formulanya. Dia datang daripada formula work. Okay, saya ulang balik lah. Okay, tapi tak nampak yang ini. You ingat balik, power, apa formula power equals to work over time ataupun energy over time. So ada perubahan. Okay, because this is average bukan instantaneous. So dia bawa naik atas, so P dt equals to dw equals to du. So this one lah dia samakan P dt equals to du. So dari situ you will get du equals to Li di. Okay, so since we get d here, we need to what? Biasalah kita kena integrate. So when we integrate du, we get u. When we integrate I di, because I is here, so when you integrate is plus 1 so 1 plus 1, so that's why you get 2. So setengah bawa turun bawah, so that's why you get u equals to half Li squared. So do we need to know the derivation? Yes. Why? Because dia bagi tahu tadi dalam learning outcome you need to derive. So this why you need to know lah dia punya derivation. So derivation ni kena practice lah buat 2-3 kali, actually you boleh ni lah. So kena tahulah dia punya derivation. Tapi setakat ni I don't think the question will come out in derivation because there's a lot of calculation they can ask you. Okay. So kalau untuk case self-inductant, so kita menggunakan solenoid. Okay, ni formula solenoid. So dia substitute L masuk dalam ni. So that's why you akan dapat U equals to half mu naught N squared A I squared over L. This one and this one I think given inside your exam nanti, the given. So you tak perlu hafal, tapi because the learning outcome say you need to know the derivation, you have to know lah the derivation. Derivation tu setakat ni je, yang ni je. Setakat ni je. Yang ni derivation untuk half Li squared. Okay, soalan dia. Okay, soalan dia tak susah. Okay, kalau you tengok this one, we have solenoid, we have length, then we have number of turn, we have diameter D. Okay, they ask you to calculate self-inductance. So they ask you to calculate L. So L tadi ada banyak formula L, but since they already mentioned this is solenoid, so you terus guna formula solenoid. Formula solenoid, selalu soalan memang suka solenoid lah. So you use the formula of solenoid. L equals to mu naught N squared A over L. So mu naught you take from the depan yang dekat you punya apa list constant. N is given 100 turns ada area. Okay, since dia adalah bentuk solenoid, so you akan guna pi r squared. Area sama dengan pi r squared. Sama dengan pi d squared over 4. So dia guna d squared over 4 lah. So you masukkan, you dapat area divide by length. So they also give you length. So you akan dapat L. Soalan dia very direct, tak susah sebenarnya. Cuma masalah dia adalah you have to know L tu untuk siapa, L mana you nak guna. Sebab you ada dua, one coil, one solenoid. Okay, soalan number B. They ask you to find energy store in the solenoid. We have the formula for energy store, right? Untuk solenoid tadi, U equals to Li squared. So L tadi dah jumpa, I pun dah ada, so you will get 3.96 times 10 power of 5 unit the joule. Ataupun you guna satu lagi formula lah, U equals to half mu naught N apa tadi? N squared ke? Ni. Boleh je nak guna yang ini. Mu naught N squared A I squared over L. Cuma panjang lah. Because you dah ada L, buat apa you nak guna cari tu? It's waste your time lah. Okay. Boleh dia tak susah, cuma dia kena ambil masa untuk faham. Okay, the last subtopic is mutual inductance. The one that we learn tadi ada satu self-induction, so the second one is mutual inductance. So you need to define mutual inductance, and you need to use mutual inductance between two constant solenoid. So M12 equals to N squared, V12, I1 equals to mu naught N1 N1 and 2A over L. Okay, what is mutual inductance? Gambar ajar dia senang je macam ni. Okay, so kalau you tengok ni, yang tadi self-inductance, you only have this one. You have solenoid with a battery. But for mutual inductance, mutual, when we're talking about mutual agreement. What's mean by mutual? Mesti ada persetujuan. So mutual, we have two, ada dua kawan. So one with a battery, the coil one with a battery, coil two without a battery. Dia hanya ada galvanometer. So what happens when you switch on, there are current flow. So this one solenoid adalah sejenis conductor. So bila ada current datang, so they will become CCC, current carrying conductor. So bila wujud je CCC, dia akan menghasilkan magnetic field. So ni B ni. So dia menghasilkan magnetic field. So this magnetic field will be experienced or will be filled by coil 2. So coil 2 is duduk nearly, dia duduk memang dekat-dekat. So dia rasa. So kalau saya cakap dekat kelas saya, awak ada dua kawan. B ni saya cakap bangga. So kalau awak rasa B, orang sebut B ni, so awak akan rasalah B because you are too close. So that's why dia akan rasa B, this one lah. Okay. So what happened here? B here initially is 0. But since dia rasa the B from the coil 1, so B here will be increasing. Okay. The current I produce a magnetic field line. So inside it, this field line also pass through coil 2. So B ni dirasai, nampak ni, yang warna hijau ni dirasa. Okay, so what happened? The current I1 change with time, the magnetic flux through the coil. So I1 and I2 also change with time. Due to the change of magnetic field, so dia akan wujudnya apa? Induced EMF. So akan wujud induced EMF. In other words, the change in current one coil lead to the production of induced EMF in the second coil. So, which is known as magnetical linkage for the first coil. So, this one we call it is mutual inductance. So, mutual inductance is the process producing by induced EMF in another coil due to the change current in another coil. So, maksudnya dia proses menghasilkan induced EMF due to the change current in another coil. So B yang changing the current, but the coil 2 the one that produce induced EMF. Okay, but for self-inductant also at the same time, self-inductant occur in coil 1. So dalam case tadi, saya tengok balik, we have two mutual inductance happen. Okay, one mutual inductance happen at here. Ni, mutual inductance happen at here. Kenapa? Because dia tak produce current. B happen here. Current produce. So ada B. B meningkat. So apa berlaku? B ni passing through. Dia boleh cross the next coil. So the next coil experience B. So when dia experience B, dia akan jadi CCC. Current carrying conductor. So by using right hand grip, you akan dapat dia punya deflection lah. So mutual inductance happen here. At the same time, dia cakap tadi, at the same time, self-inductance happen. At the same time, self-inductance happen. Ni, self-inductance happen here. Kenapa self-inductance happen? Because remember back, self-inductance dia jadi kat seorang-seorang. Dia ada bateri, dia on. So bila dia on, B meningkat, dia tak suka, Lenz law tak suka, so dia akan turun. So kita ada dua inductance happen. One, self-inductance in coil 1, mutual inductance in coil 2. Okay. So itu adalah dia punya situasi lah. Okay, formula ni saya tak nak tekankan because formula is given. So you don't have to worry about formula. Cuma you kena be careful dekat sini. When induced EMF, you need to find induced EMF 2. The I current that you kena cari adalah I1. Bila you nak cari induced EMF 1, the current that you need to find is 2. Sebab you ingat balik tadi mutual inductance kata, the induced EMF adalah due to the change current in another coil. So that's why when you want to find E2, please use I1. When you want to find I1, please use I2. Okay, formula ini tak kisah sebab apa M12, M21 are same. M dia adalah sama saja. Unit sama Henry, dia sama je dengan self-inductance. Okay, ini adalah dia punya formula. Okay, ini formula adalah untuk yang Faraday lah. Faraday V equals to dV over dt. Bila ada N, just darab N. Okay, lepas tu tadi awak dapat V equals to M di over dt. So dia substitutekan dua formula ni. So apa yang boleh cancel? Negatif, negatif. So dt, dt. So apa yang boleh berlaku? Integrate di will get I, integrate dv you get V. So you will get I ni bawa ke bawah. So you get M12 equals to N2 V2 I1. Nampak ni? Dia nak cari 2 punya tau. Tapi dia guna I1. But for M21, N1 V1 I2. So yang ini please ya. Tekankan nanti dekat dalam in your tutorial please tengok balik yang ini. So M equals to N V I1 or N1 V1 I2. So I1 and I is very important. M tak kisah because M12 equals to M21 tak kisah. Cuma tengok question dia nak siapa? Dia nak M1, dia nak N1 ke N2? Kalau dia nak N2 you have to use I1. Kalau dia nak N1 you have to use I2. Call 1, call 2 lah. Ini contoh je lah di mana N1 tu apa cikgu? Primary coil. N2 is the secondary coil. Dan dia selalu berlaku dekat solenoid lah when there are two solenoid. Okay, so yang ini formula biasa yang ini formula ada, tak perlu risau, tak perlu hafal. Okay, kalau you tengok dekat sini, dia menggunakan V equals to BA cos theta yang general tu Okay, dia guna B siapa? Dia guna B solenoid. Ini dalam assignment banyak you jumpa ni. Okay, dia kata no magnetic flux linkage, tak ada kebocoran. Magnetic flux dekat N1 dengan N2 sama. So that's why V1 and V2. Sebab tadi you tengok ada berapa coil? Ada dua ni, ada dua. Ada satu dengan dua. So dia bayangkan dua-dua ni sama, tak B. B yang terhasil ni, B yang dirasai oleh N1, B yang dirasai oleh B2 is the same. Because dia dekat same side, dia duduk kat region yang sama. B dia sama lah. Okay, so magnetic flux dia adalah sama. So menggunakan M12 equals to N2 V2 I1. Tengok ya, ini 2 punya tapi dia guna I1. Tengok 2 ini 1. So M12 equals to N2 I1 tapi V2 ni dia guna yang solenoid punya lah ni, solenoid punya. So mu naught N1 I1 A over L. So datanglah formula M equals to mu naught N1 N2 A over L. Okey, formula memang macam menakutkan tapi saya rasa soalan dia tak susah sebab soalan dia sangat direct lah. Yang ini you buat dekat tutorial lah nanti ya, you tengok kat tutorial. Okey, so saya nak tunjukkan video ni tapi saya tak tahu tak boleh, saya takut tak dengar. Tak. This one adalah demonstration of electromagnetic induction. Kalau you tengok, okay, ini adalah the one that you learn early lah. Okay, dia nak demonstrate Faraday law. Okay, so dia kata Faraday law will happen when there are change. Dia menggunakan induction coil dengan permanent. Ini this one, the first one you learn. Coil, galvanometer, permanent magnet. Okay. So kalau you tengok this one, ini adalah you punya solenoid. Ini dia dapat tak? Dia gerakkan siapa? Dia gerakkan magnet. So what happen? There are current flow. Dia tak pasang langsung ya dekat battery. There are no battery inside the experiment. Okay, yang ini mutual inductance. Yang tadi self-induction. Yang ini mutual inductance. Okay, ni ada. Okay, one is connected to a battery. Ni battery dia. Okay, ni mutual inductance. Okay, so if you look at here, dia connected lah. Dia close, very close. Okay, dia kata dia switch on the battery. So what happened? When the battery is on, tengok. Dia daripada maksimum pergi zero. Lepas tu dia, kok apa benda yang berlaku ni? Apa benda yang berlaku ni? Okay, let's watch again. So from maximum, okay, kenapa jadi macam ni? Because ada berlakunya Induced Emf. Ini adalah induction dalam coil lah. Yang ini ada alternating. Pernah jumpa ni rasanya dekat tutorial ni, gambar ni alternating. Yang itu direct current ya, yang ni alternating. So kalau you tengok macam mana dia buat eksperimen ni in alternating, so dia bergerak. Kenapa dia sentiasa bergerak? Because alternating is current ulang alik lah. You can clockwise or either clockwise. Tadi tak, tadi direct current. So these two experiment actually prove the Faraday law punya equation lah. So ni Faraday yang awak belajar ni, Faraday. So induced EMF hanya berlaku bila change in magnetic flux. Mula ni. Okay, boleh. Pula. Okay, boleh tak ni? Saya buka kat sini, saya kat sini. Okay, tak apa. Kalau siapa-siapa yang ada masalah, you can go back, tengok record ni balik.